Chapter 8, we start looking at how to count things. So first thing we're going to count are the number point q, and what we essentially have are three choices at the outset. And we have three different paths that we can take. So 1, 2, 3. But along the way there are different branches we can do. So what I'm going to do is I'm going to break this into a top choice, a middle, and a bottom choice. The top way of going, we have one choice there, two choices there, and one choice going from D to Q. So the top way of going, what we can do is we can multiply each choice that we have along the way. 1 times 2 times 1 gives me two different paths total from P to Q. Along the middle path, there's one choice when we first start going from P to B, but then from B to E we have three choices we can make. From E to G we have two choices, and from G to Q we have one, giving us 6 unique paths that we can take. Along the bottom, P to C there's one choice, C to F there's 3, and F to Q there's 1. So 3 choices there for a total of 11 ways that we can get from P to Q. I'm now adding these together. One form that's used a lot in counting are factorials, and the factorial is the exclamation point that you see. And what it means is it means take a number and each successively smaller integer after it and multiply. So we want to express this in only factorials. Well, the bottom, we can see that that's 5 factorial. But the top isn't a factorial. We left off a bunch of terms. We left off times 7, 6, yada, yada, yada. But if I'm going to multiply those up there to give me 10 factorial, I'm going to have to do the same thing down here on the bottom. So in changing the numerator to a factorial, we also have to divide by something in a similar fashion. So there is our factorial form. Here we have a chess association. It has 16 teams. How many ways could the top 8 positions be filled? Well, we can look at 8 positions. The first position, there are 16 different things that could go there. The second place can have 15, then 14, 13, and all the way down here. This is the same thing as 16 factorial divided by 8 factorial, or what's commonly referred to as 16p8. Permutations of 16 things taken 8 at a time. In other words, how many orders of 8 can be made from 16 things? And that's something that can be calculated within your calculator. And we'll come back to that in the next section if you're not sure how to go about that. But now we're going to count with some blocks. We have blocks A through E. So A, B, C, D, and E. How many ways can we order these blocks, beginning and ending with a vowel? Well, I like to think of 5 spots here. The first spot, there are 2 numbers that could go there. The second spot, 2 letters I should say. The second spot, there are 3 consonants that could go there. The third spot could have 2, the fourth spot could have 1, and the last spot gets the other vowel by default. So what we have is 2 times 3 factorial, which is equal to 12. 3 factorial is 6, times 2 gives me 12 ways. Now we have books on a shelf. How many ways can we arrange these books, provided that A and B have to be right next to each other? So in essence, A and B could be treated as being one item that just have to be together. So instead of having 6 factorial, we would be looking at 5 factorial. But we have to multiply that by 2, because we could go BA or AB within that ordering. And that's just a computation that needs to be made. How many orders can 3 people be arranged? Well, 3 factorial. 3 times 2 times 1. Around a circular table, it's actually only going to be 2 factorial. Because if I have this circle, A, B, C, and then I have A, B, C, or A, B, C, these are all, in essence, exactly the same, all 3 of these. There's no reference to say, well, I'm sitting in this specific seat. It's a round table. There is no markers saying this is the beginning. These 3 things are just rotations of each other. So what we have to do is, when we'd normally be taking 3 factorial for 3 items and how many orders we can make, we have to divide by 3. So the number of factorial actually goes down by 1. So there would only be 2 ways 3 different people can sit around that circular table. Now, if we have a circular table with a point of reference, say a window behind one chair, what we're doing is we are calling it a linear arrangement then. We're giving one point as a point of reference. And as soon as we introduce that point of reference, it goes back to being a linear arrangement. So we would call it 3 factorial.